Hello students, now let us start with RSA algorithm. Now as I told you that the basic concept or basic application of this topic is in cyber security or the cryptography. So in that cryptography there is a very important algorithm called RSA algorithm which is used for as a security communication. Like if you know that whenever we transfer the money OTP will come, or for everything nowadays OTP will come. That is all is the cryptography work. Okay. So now we have to discuss that algorithm, RSA algorithm. Now what is a cryptography? Cryptography is a study of secure communication which allows sender and the intended recipient to view the contents. Right? So that is what is the basic definition of cryptography. Now, for every user, there will be a public key. Okay, public key means E comma N. What is E? What is N? That I'll explain you. And this will give you the first category of question where I will be asking you find the public key. Okay, that time I'll be finding out this E comma N. And what is E? What is N? I'll tell you after a few minutes. Okay. Then there is a private key. So I can ask you a question, find public key. I can ask you a question, find private key. Okay. Now this public key is known to all the users and it is used to encrypt by all the users. Okay. Private key is secret and it is used to decrypt the message. So this is the first concept. What is a cryptography? It is a study of secure communication, right? Which only give information to sender and the intended recipient. And I have a public key and a private key term, and I will be in numericals. I will be finding out this public key and private key. Okay. So this is the first thing. Now what is the second thing you need to understand? What is encryption? Now it uses an algo and a key to transform an input, which is a plain text. Plain text means what I am writing, the simple English. Okay. So there will be a plain text which will be an input which I want to convert. And that converted one is called the ciphertext. So basically encryption means conversion from plain text to a ciphertext. And the formula I will be using for encryption is C congruent m to the power e mod n. Once you get your private key and the public key, you will have the value of e and n. So that I will be using, and m will be given in the question, and they will ask you ki encrypt m. So you will be encrypting m by using this formula. So first you will be finding out your public key or private key to get the value of e. And from that then you will use this formula and you will get the answer. That we will learn in numericals. Don't worry about it. First understand the theory, because you should not get confused when they give you the words like plain text, ciphertext. So first understand the theory part. Okay, now this is the one thing. This is the second point we understood. Now what is the third point? Now in RSA, plain text, okay, plain text and ciphertext are integers. Okay, plain text and ciphertext are both in terms of integers. Like whatever plain text I am giving, that will also be a number, like our OTPs. Okay, from 0 and between 0 and n minus 1, they will be numbers from 0 to n minus 1. For some n, RSA is a key generation process. So basically I will be generating a key and it is a process. RSA is a key generation process. So we are generating a key. And now what I will be using, how this plain and cipher text are correlated, this will be the codings I will be using. Whenever A will come, I will put a number 0. And whenever B will come, I will put a number 1. C 2. Like that, Z will be 25. This is the code for RSA algorithm only. Different algorithm have a different correlation given. Okay. For example, if I give you 0 4. So 0 4 will be AE. A and E. D and E. So 3 and 4. Same way if I am writing DB. So D is what? 3. B is what? 1. So it will become 3 1. So this is what we will be doing. plain text and ciphertext. So they are correlated by these numbers. But yes, in the question, even when I am saying I am giving you a code, then it will be M. If I am giving you, that will be certain number. Like if I say 56. So what you will be doing, you will be writing letters for this. Then you will be encrypted and then you will tell me the answer and the answer will come in number. And then you will give me the answer in terms of letters. So this is how it works. Now, what is the next thing? The steps how RSA work. So now I'll explain you the algorithm and how the questions you have to work, that I'll explain you in detail. Okay. Now, what is a step 1? I'll write here RSA algo. See, the question will be very lengthy in this case, but they are easy. They are not difficult. Okay. So, what is your step 1? I will define 2 prime number. Okay, I should take it capital D. I will define 2 prime numbers P and Q. Okay, these numbers will help me to generate a key. Step 2, I'll say n is equal to P into Q. So now I got the value n. If you remember, so many places n was coming in all the formulas. Correct? Now n is equal to P into Q. Now what is step 3? I will define phi n. Now recollect what is phi n. If you go back to the previous videos, I have explained you phi is the Euler's function and it gives me the count of numbers before n which are co-prime to n. For example, if I talk about 4. So before 4, what are the number? 1, 2 and 3. But co-prime number with 4 is 1 and 3. So phi n will become, phi of 4 will become 2. So this is how phi work, Euler's function work. Then in one shot, I have given you the properties of this Euler function. Those properties help me to calculate the value quickly without writing the factors like this. Okay, and the most important 2 properties which I used there was, if n is any prime number, then phi of n is equal to n minus 1. So this will be very helpful here because I am taking P and Q as prime numbers. And one more property was that if phi of AB I want to calculate. Okay, so it will be phi of A into phi of B. And obviously here both the numbers P and Q, when I am doing phi n, it is phi P into Q basically. So it is phi P and phi Q. Now both are prime. So I can easily write here n minus 1 formula I can use. So I can directly write here P minus 1 and Q minus 1 as my formula. For P, P minus 1, for Q, Q minus 1. And if you don't want to use it, I told you this is also a method 1 upon 1 minus 1 by P and 1 minus 1 by Q. This is what we were using in maximum questions when you were doing the Euler's theorem. Okay, so you can directly use this formula here, or if you want to go by this method, no issues, you can use. I just need the value of phi n. Okay, now once you get the value of phi n, now I need to define my E. Okay, now what is this E? So step 4 will be find E. E is any number between 1 and phi n. In most of the question, this E will be given or some source will be given through which I can find out E. Now this E is the number between 1 and phi n such that the GCD of phi n comma E is equal to 1. Okay. Now step 5 will start the main calculation. Step 5 you will do compute ED congruent 1 mod of phi n. Okay, I'll just erase this part to avoid the confusion. Since you understood this part, let us remove this. I just want it to be neat and clean. Okay. So now here you see, here you understand very carefully. In step 4, I got the value of E. When I substitute that value here, this linear congruence I will get. Phi n value already I calculated in step 3. E value I calculated in step 4. When I substitute both the values here, I will get a simple question of linear congruence. You can check the video for linear congruence and learn how to solve it. Okay, because in every question you have to solve. That is why I said this question is a lengthy question. Okay, now with this you will get the value of D. Once you get D, you can define your public key as E comma N and private key as D comma N. Okay, so this is one till this point there is one category of question where they ask you only public key and private key. So we will be doing till this part. Okay, now sometime they exceed and they ask one more step. What is that step? They will give a number and they will ask you encrypt it. If they ask you to encrypt it, they will give you the value of M. Okay, they will give you the value of M and you will use the formula C congruent M to the power E mod N and your C will be the answer. Now step 8. If they ask you to decrypt, okay, in that case they will give you C. So C will be given and you will use the formula M congruent C to the power D mod N. So you will get the value of M. So understood this point? So this will be the step if they want to ask a small question, that is also not small, but yeah, okay question. In that case, they will ask you only the public key and private key. Okay, and they will define P and Q in the question. Using that P and Q, you will calculate phi n. Now after phi n, either they will give you D or they will give you E. Now using that D and E and using this formula, you will find out the other thing. One thing from E and D is given, then other you can find out by linear congruence. Okay, based on the value of E and D, you will be defining your public key and the private key. This is one category of question. Second category, they may ask you to encrypt a given number. Given number will be plain text, which is represented by M, but it will be a number like 45, 46 like that. Then using the formula this, you will find out the C, which will be your answer. If they ask you decrypt, means they will give you C. And then you will find out the value of M by using this formula. So here you should not get confused. You should make some story and remember it. Okay. So remember like this, when they are asking to encrypt, E is going in power and it's about me. So M and E are together. So definitely you are finding out C. And then once one is clear, then automatically second you can write. Correct? So remember, encrypt means E will go to the power, it will become me and I will find out C. This is how you should remember to avoid the confusion in exam. Because in stress, you usually forget what was the formula and they look similar. So there is a high chance of getting confused and doing the mistake. Okay. So now this is all about the RSO algorithm. Now just look at this one. Sometime they will ask you to encrypt a big word. For example, if I ask you encrypt stop, S-T-O-P. So now if you go back and see that table which I gave you, where A is 0, B is 1 like that, S is 18, T is 19, O is 14, P is 15. Now this much big number if you want to deal, it will be very lengthy because M is given, you have to find out C. Right? So if I start with this, so basically I am asking you to find out C congruent 18191415 to the power E and mod N. So it will be a huge for me. So I will not go by this way. What I'll do, I'll split it up into two parts. I'll split it up as M1 and I'll split it up M2. Then I'll encrypt M1 and find out C1 for it. I'll encrypt M2 and find C2 for it. And my final answer will become C is equal to C1, C2. Now this will give me again number. 8 numbers it will give. Again I'll make the pairs and I'll write down the letters for it. So they gave me stop. I will also give them back something in English. So that is a conversion from plain text to ciphertext. Understood? So this is what the algorithm works. This is how it works, right? So as I told you, I can ask you 3 categories of question. One question when I'll ask you only the public key and private key. The second question, I can ask you to encrypt and decrypt the simple small numbers. And the third, which is the most lengthy, is encrypting such a big number or decrypting such a big number. So that is the reason it is very important to learn how to use calculator to solve the linear congruence, because there only you have to struggle in this. Okay, I hope the algorithm is clear to you. In my next video, I will solve 2 questions of this, and then I will prepare a short in which I will do one more question, and then one full video I will be doing to solve this type of big question like stop. Okay, thanks a lot.